So we arrived at this little problem where we have this car which weighs 1,000 kilograms, and to store all this energy that is in the moving car into a spring when it has to stop for a traffic light, for example, the spring would need to have a weight of a mass of 455 kilograms, which adds to the weight of the car if you want to take the spring with you. So the new weight of the car would be not 1,000 kilograms, but 1,455 kilograms. And if this car is moving at a speed of 20 meters per second, then all this kinetic energy is now bigger, and to have a spring that can store all this energy, you would need a spring of 662 kilograms, which of course adds to the weight of the car. So the car is now no longer 1,455, but is now 1,662 kilograms, which is moving at a speed of 20 meters per second. So that adds to the weight and adds to the energy. So you would need a spring of 756 kilograms. Well, to work around this problem, what you have that you always add weight to the car, which adds energy to the moving car, which adds to the mass of the weight of this spring that you need to store all the energy in. The work around this problem is as follows. You take of course the energy, the kinetic energy of the car must be equal to the specific energy of the spring mass times the mass of the spring. So that all the kinetic energy has to be stored into the spring. If we write it like this, like the mass of the car, well, we know that the mass of the car is not only the 1,000 kilograms of the car itself, but also the mass of the spring. So we have the mass is 1,000 plus the mass of the spring times velocity squared, and this is 400. Let's write it like this. 400. It's 20 squared. Okay. Must be equal to the specific energy of the spring, which we know it's 440 joules per kilogram, times the mass of the spring. So we have now one equation with only one unknown in it, so we can rewrite it and calculate what's the mass of the spring. And if you do it like this, then you will add up, come up to the following conclusion, that the spring, if I say it's really 440, then the spring weight must be 833.3333, etc. kilograms. So this is the work around the problem of this never-ending coming closer to the real mass of the spring. So, and now we can concentrate on the other stuff that I promised to let you know about spring materials and shapes and stuff.